Hello, welcome back. So, this is just a continuation from what we had started off previously, which was the quadratic number patterns. Then, for this upcoming video, which is starting from this one, I'm going to be dealing with the geometric and the arithmetic. So, I want to start off with the arithmetic number pattern. So, for the arithmetic number pattern, we know that the arithmetic pattern always takes the form Tn is equals to a1 plus n minus 1d, where d is our common difference. Remember, arithmetic has a common difference. Then a1 is just our first term of that pattern. And remember, when you're summing up all the values of your number pattern, we're going Sn, and Sn is going to be n over 2 multiplied by 2a plus n minus 1d. I actually have a good memory, and that's how you find the sum of the first n terms. And the other thing we have to remember is sigma notation. And sigma notation is the way of showing a sum. Okay, and we first draw the sigma symbol, and then we put in our general formula here, and then n is equal to, and then we'll put in our first term, whatever the first term number is, and then here we're going to put in the last term. That's generally how that is. This is the tip of the iceberg. Then there were a little extras, right, where the kind of questions where you were asked to find values of a non-successive term, where they would give you term number 7 and maybe term number 2, and you have to work with that. And the way you had to do it was by simultaneous equations. Okay, so we'll set those aside, and then we're going to do this as a compounded question. So I'm gonna just okay, let me just grab the pen and proceed. Let's begin with what we know. Let me make up a question. Okay, let's suppose there's the question 3, there's the pattern rather, 3, 6, 9, 12, 15, 18, 21, thy kingdom come. Okay, let's suppose this is the pattern, and we were finding the nth term of this pattern. This would be easy, right? If I was finding the nth term, I would first find the common difference. This difference would be common, because 6 minus 3 is 3, and 9 minus 6 is 3, 12 minus 9 is 3, and it keeps going. So my common difference is a 3. Then to find the nth term, I'll say Tn is equals to a1 plus n minus 1 d. Then my a1 first term is 3 as shown, plus the n minus 1, and then my common difference is 3. And then I'll then simplify. This is just 3 plus 3n, because 3 multiplied by n, and 3 multiplied by negative 1 is negative 3, and then I'll end up with 3n, because 3 minus 3 is 0. Okay, then this would be my nth term, isn't it? And then in the case where I would like to sum, let's say the question says, what is the sum of the first 5 terms of this equation? So what they're saying is the first 5 terms, meaning these 5, what is their sum? If I add all these, meaning it becomes a series, what answer will I get? So what we are saying is, what do we get if I sum of those up? So to do this, we said the sum of n terms would be n over 2. Remember, this is arithmetic. N over 2 multiplied by 2a, right, plus n minus 1 d, and then we close that off. Then we make our substitutions. Our n is just the number of terms that we are essentially adding up, and this is just 15. So it's 15. So I've got 15 over 2, and then 2a is the first term that I'm adding within this series, and the first term in this case is just a 3, plus my n, well, we said is 15 minus 1. My common difference is 3. We have it there. Okay, then let the calculator do the work for this question. So we're gonna push this calculator aside and then use it from there. So what we have then is I'm just gonna type the whole thing in as is. So that's 15. Oops, I thought I had the fraction there. Okay, that's 15 divided by 2, then multiplied by 2 by 3, plus 15 minus 1 is just a 14, so let's have that in there, and then 3, and then close off the bracket, and this gives us 360. Okay, that's what we get from the calculator, and we're gonna test it out now. So it just says this will add up to 360, but let's test it out manually within the series. So if I grab onto the calculator and add up those things, I would have just 3 plus 6 plus 9 plus 12 plus 15, and I actually get 405. Where the hell did I get? Ooh, my bad, my bad, my bad, my bad. The number of terms, I added 15 terms in here, not not so here I was using n of 15. I was adding up the first 15 terms when I'm actually trying to add up the first 5 terms. Ah, there we go. So if we go back to this formula, so we should get rid of this. Where's my eraser? Yes, there we go. So we should be actually getting a value here, which we're about to calculate that value. So what I'm saying is if we add these up, we'll get wait, this would be 5 over 2 based on the formula, multiplied by 2 by 3 plus, and 5 minus 1 is a 4, and multiplied by 3, and then I'll close that off, and then we get a 45, which is what I just did now. So that just proves the formula. Okay, so let's set aside the calculator, so we get 45 there. So how do I represent this in sigma notation? Well, in sigma notation, remember right now I just added the sum of the first 5 terms. If I was representing this in sigma notation, I would first draw my sigma symbol, and then remember here you're going to put in your general formula, and my general formula is just 3n, and I'm starting from n equals 1 all the way up until 5. That's what I'm doing. So this is the representation in sigma notation. And because my calculator is actually smart, I can actually simplify the sigma notation to test it out. We should be getting 45 for this. So let's test that out. So with this calculator, I can just go through and say shift and that, and then I have the whole sigma thing, and then I can say 3. Because I don't have n, I'll make use of x. Okay, and then if I go down, this begins at 1 all the way up until 5, and we still get a 45 from that. So that just proves the sigma notation as well. So when you draft the sigma notation, that's the form that it will take. Then let's talk about non-successive terms. So I know I gave you the pattern as 3, 6, 9, 12, 18, and so on and so forth. 18, 21, and it keeps going. This is 3, 6, 9, 12, 15. But let's just say, for instance, this time a question comes with the very same pattern. However, they do not give you the very same terms that they give you. They do not give you terms that follow one another. Let's just imagine they give you term number 3 and maybe this one, and they want you to draft that nth term and proceed with the other questions. Okay, so this time they just gave you the third term. So there's 1, 2, 3, 4, 5, 6, 7, and the seventh term. So this time they're not gonna give you these guys. They're not gonna give you these. So the question will just come, they'll be like, in an arithmetic sequence. Note, they do tell you that it's an arithmetic sequence. Okay, so they'll tell you that the third term is equal to 9 and the seventh term is equal to 21. And then they'll be like, find the common difference or find the nth term. We're gonna find both in this case. Okay, so what you would do is you would draft a nth term that is incomplete for each one of those values. I'm going to show you two ways. I'm also going to show you how to check your answer with a different formula. So for this, we're going to first start off by drafting an nth term for this. We know that Tn is equals to a1 plus n minus 1 d. So I'm going to do this for this one. So in this case, the Tn is going to be 9. That's just the term value. And then a is the first term, I don't know it, plus n, this is the third term, likely 3 minus 1 d. So I've got two unknowns in this case, so I'm just going to clean this out. A1 plus 3 minus 1 is 2, so this becomes 2d. So 9 is equal to 2d. And then I'm going to make the same substitution for this one. So we still know that Tn is equals to a1 plus n minus 1 d. I'm going to make the substitution again. So Tn is going to be 21, and then a1 is unknown, plus n, this is the seventh term, 7 minus 1, and then the d is still unknown. Then I'm going to just clean this out again. A1 plus 7 minus 1 is 6, and that's 6d. So one of these formulas I'm going to have to take and make a the subject of the formula. Let's suppose I chose this one to make a the subject of the formula. So if a is the subject of the formula, then a1 was going to be 9 minus 2d. So this is something that I just came up with. Okay. However, I'm going to make this substitution into that formula. So what I'm doing is actually doing a simultaneous solve. So I will then proceed to then say into this formula, wherever I see the a, I'm going to substitute the 9 minus 2d. So essentially 21 is going to be equal to, instead of a, I'm going to have a 9 minus 2d plus 6d. And then I simplify and solve for d. So 21, actually I can transpose my 9 right now. So 21 minus 9, we're gonna start off there. So 21, not 9, 21 minus 9, it gives us 12. Nothing fancy there, we just get a 12. So I'm just simplifying the fact that I'm gonna get a 12 there, and this is going to be 9. Okay, the 9 is actually gone. Okay, then here we actually have negative 2d plus 6. So negative 2d plus 6, these are like terms. So I'm going to have negative 2 plus 6. And negative 2 plus 6, that just gives us a 4. A positive 4 for that matter. So I get a 4d. And then 12 divided by 4, then I should get what I need. So 12 divided by 4 gives me 3. So d is equal to 3. That's my common difference, which you know, obviously, because come on, we did the very same pattern. I just complicated things a little bit. And then how would I find my a? To find my a, I can then take my d and put it into any of these formulas. It can be this, no, not that one. It can be this formula or this formula, any of those two. I would prefer going to this one because it's actually straight away. So I'll use the formula directly for that and see if I can get back my d. So I'm gonna hook up the calculator and then use that formula. So we've got a d of 3. So I'm going to then say, instead of a, I'm actually trying to figure out the a. So 9 minus 2, and the d that I actually got is a 3. And that gives us the first term of 3. Makes sense now. So now I've actually solved the whole thing. Then I can plug it back into the Tn and I'll have the full end term. This sounds like a long hassle to just do something so simple. So to test out your answer, we're gonna set that aside. So to test this thing out, okay, so I'm just gonna jot down the values that we got. We got an a of 3 and a d of 3 as well, after doing this whole long method of simultaneous. So now I'm going to just get rid of these stuff, hoping that you've copied them down. Okay, so we'll say goodbye to them for now, and we'll erase. Oops. Okay, so that's just T7. Okay, so how would I know that the values that I got are actually correct? So this is where you would use my formula. My formula just says to get the common difference in an arithmetic pattern, you're going to say a of y minus a of x over y minus x. Nash, you lost me. Don't worry. Just remember that y is the largest term number. Always. Always. So y is the largest term number. So to make these substitutions, first of all, I will then first, before I substitute into the numerator, I just need to figure out what the y is. Then I'll know what the ay is. So y is the largest term number. The largest term number, remember term numbers are these ones, term number 3 and term number 7. The largest term number is 7. So y is actually 7. And because y is 7, then x is 3. Like so. Then y is 7, and clearly then ay has to be the value of that, which is just 21, minus, and then the other one would be the ax, which is just 9. And then we simplify this whole chunk, and we'll let the calculator do this for us. So for that, this is just a fraction, so we'll say 21 minus 9 divided by 7 minus 3, and we get 3. That's our D done. That's just our D. So we just get 3. It sounds very discouraging. Anyways, proceeding, then how would we find the others? So this is where you get to pick any of your formulas. You can pick this or that. Let's just suppose I choose this one. So I'm going to work with this one. One thing I know for sure is that Tn is equals to A1 plus n minus 1 D. Then A is the first term which I'm actually looking for in this case. I don't know it. However, I know the Tn to be 21. Then plus n in this case is a 7 for this one. Is 7 minus 1. And then D is the common difference which I just found to be a 3. Then this is just an easy solve. Matter of fact, you can do this with your eyes closed. So I'm just going to do this with the calculator. So set this aside. Then for the calculator, I'm going to make it solve it for me. So 21 is equal to a, which is unknown. I'll use x in this case, plus, and then 7 minus 1, and then instead of a d it's just a 3, and then shift solve and equals to, I have a syntax error there because I don't have a bracket there. There you go. Then shift solve equal to, and then we just get a 3. So that means my a is 3. So a1 is 3. That's how we do the non-successive terms when it comes to the arithmetic patterns where they just seem incomplete. So we of course have to do at least a past paper on these. Yes, we're going to do that. So if we go over to the next page, we're going to find a couple of these past papers that I've set aside. I don't know if, okay, yes. So here we go. Come on. All right, so here we go. Actually, that's a quadratic, that's a geometric. You can't tell me I never got a no arithmetic number pattern, but that's okay. I can go and grab a question on arithmetic patterns. So I'm gonna take a question now, and then we can go through that question. All right. So I use this page. So I'm just gonna clear out everything that is on this page. All right. So this is the question. So this is from November 2014 as well, and here we go. Let's get started with that. So you're given this arithmetic series and this goes all the way up to term number 251, and they want you to write down the fourth term of this series. This is as dumb as it gets, but anyways, we're given three of those, so let's just find the common difference. So we're just going to say 9 minus 2, and 9 minus 2 is 987. That's just 7. I shouldn't bother myself, so that's just 7. So I get 7 for this. So my fourth pattern would just be 16 plus 7, and 16 plus 7, I'm not good with mental maths, so I'm gonna have to be slow on this one. 16 plus 7 is just 24, so we're good. That is the fourth term. It's 24. Calculate the 251st term of the series, in other words, the last term. So to do this, now I actually need the nth term of this. So to find the nth term, we know that we start off with Tn is equals to a1 plus n minus 1 d. Then I make my substitutions. So my a1 is the first term, which is actually 2, first term of the pattern, plus my n minus 1, and my common difference is 7. Then 2 plus 7n minus 7, because 7 multiplied by n is 7n, and 7 multiplied by negative 1 is negative 7. Then I'm going to get 7n, and then 2 minus 7 is like 7. This is just like 7 plus 2, negative 7 plus 2, 7, 6, 5. That's going to be negative 5. So we get a negative 5 there. Okay. This is what we get for the nth term. However, we need to find out which one is the 251st term. So we're going to be actually finding n equals to 251. So what I'm doing then is saying Tn is going to be 7. And instead of n, it's 251 minus 5. And then we let the calculator play this game for us. So for this, it's just going to be 7 by 251 minus 5, and then we get 1752. 1752, yes, got it. So that's what we get for that, 1752. That's the value we get for the 251st term. Then the next question, they just says express this whole thing in sigma notation. So let me just get rid of this. We may not need this. Alright, so to express this in sigma notation, we're gonna first draw our sigma symbol. So we begin with the sigma, and remember we put in our general formula here, and our general formula was just 7n minus 5. Then we're beginning from n is equal to 1, because this is beginning at the first term, and then this goes all the way up to 251 terms, because that's the last term provided there. Easy as that. That's now expressed in sigma notation. Then they said calculate the sum of the series. Ooh, well, this is an arithmetic pattern, and because it's an arithmetic pattern, I shouldn't really stress too much. So I actually know that Sn is equals to n over 2 multiplied by 2a plus n minus 1d. Then I'll make those substitutions accordingly. So I'm supposed to calculate the sum, so this shouldn't worry me much. So n is the number of terms that I'm essentially trying to sum up. I'm trying to sum up 251 terms over 2 and multiplied by 2. And my value of a is the first term. This is just 2 plus, and then n is still 251. I shouldn't have closed that bracket, so this is just 251 minus 1, and then d is the common difference of 7. Then we close that off and let the calculator calculate for us and do the work for that. So I'll bring back the calculator. I'm going to set that this side for visibility. So here I'm just going to put it in as it is, 251 divided by 2. Open up that bracket, 2 multiplied by 2 there, plus 251 minus 1 multiplied by 7, and then close that bracket, and we get this 22,127. All right. All right. 22,127. Let me just double check this. Okay, yeah, that's fine. 22,127. Okay. So we get 22,127. Okay, let's just double check that answer with our sigma notation using the calculator. So based on our sigma notation, so I'll just leave it there. Based on our sigma notation, I'm just going to write down the sigma notation that we actually have, which is this one. And we've got 7n. Instead of n, I'm going to use an x. And we have a minus 5 there. And we're beginning from 1 all the way up until 251. And we get, this will take a bit, and 22,127. So we perfect. We got the sum. There we go. Next question. So for the next one there, how many terms in the series are divisible by 4? Only those that are divisible by 4. So what I'm actually going to do is I'm going to take this pattern that I actually have and begin to isolate it um, to such an extent that I only have terms that are divisible by 4. That's what I'm going to do. So I'm going to form a new pattern. So to do this, let me just clear up everything on the screen right now. So I have this, and I'm going to go manually and find everything that is divisible by 4. So I'm going to write down, kind of like a range so I can inspect them and at least have the first 2 terms or 3 terms or so, and then work with them from there. So this pattern starts from 2, and then it gets to 9, 16, and we keep on adding 7 each time. So 9, 16. Actually, I'm too lazy to be going around calculating these things, so I'll let the calculator do it for me. Okay, so I'm trying to find certain values out of this. So I'm gonna use the table. So this is just 7n minus 5. That's 75. Genius. This is 7n x minus 5. No, I'm going to begin at the first term up until, say, maybe term number 9, for instance. And here are my values. So I've got 2, 9, 16, and they keep going. So 2, 9, 16, 23, 30, and so on. So 2, 9, 16, 23, 30, 37. So 16, 23, 30, 37, 23, 30, 37, and let's probably get more just in case. 44, 51, 58, 44, 51, 58. I know this seems pretty manual, but nonetheless, then we're going to start extrapolating a, a new pattern of only those that are divisible by 4, and then count how many of those are they. So I'm going to then I'm just going to grab a new one, and then we're going to go manually. So 16, oops, 16 is obviously the first that's divisible by 4. If anyone would like to argue, you can just test your with your calculator. Okay, so if I grab the calculator there, obviously, okay, let me just clear this out and go back to comp mode. Okay, so here we know for sure 16 is divisible by 4, and that's the first one. 9 is not divisible by 4. 23 is obviously not divisible by 4. What about 30? Is 30 divisible by 4? Let's find out. 30 divided by 4, it gives us, no, that's not a whole number. 37 divided by 4. Nope, not a whole number. 44 divided by 4 should be like 11, so that one is divisible by 4. So 44 is the next that's divisible by 4. And 51 is 51 divisible by 4. Well, let's find out. 51 divided by 4. Nope. What about 58? Is 58 divisible by 4? No. What's after 58? Well, after 58 we should have 58 plus 7, 65. Is 65 divisible by 4? We can do this on and on up until the 251st term. We can do this, or we can actually find out the 251st term. So we first got let's, what was term 251? As we said, this term 251 was this one, right? um this is term number 251. Okay, so this being term 251, is this one divisible by 4? So what I'm actually doing now is I'm just trying to do a whole divide and conquer here. So what I know is I begin at 16, followed by 44, up until something. So I want to find what is the last term. Okay, so that's what I'm trying to do. So 1752, is this one divisible by 4? Yes. So what was that number? um not 5 or 4. Okay, that's all, 1752. Okay, so 1752 is divisible by 4. Okay, so now this is the pattern of only those that are divisible by um by 4. So what I'm gonna then do is find the value, the term number of the last one. However, this has its own general formula, its own nth term. So let's find the nth term for that one. Let's see why this question is actually awarded 4 marks. That's a whole lot of stuff. So what is the common difference here? So I'm gonna then just say 44 minus 16. This is normal stuff. 44 minus 16. 44 minus 16 is 28. So that means my D is 28. So I've got a D of 28. Then we know that T of n is going to be equal to a1 plus n minus 1 D. And a is the first term, in this case it's a 16, plus my n minus 1. And then D is the common difference of 28, which I just got. And then I want to simplify this. This becomes 16 plus 28n minus 28 for that. And then if we simplify this a step further, this would be 28n and then 16 minus 28. 16 minus 28 is negative 12. So that's just going to be minus 12. 16 minus 28 is negative 12, like that. This is the general formula. However, what I now have to do is find the term number for the last one, which I had stipulated before. So this time I should have a 1752, and this is equal to 20. Oops, this is equal to 28. 28 and minus 12. And then we're gonna let the calculator do the solving for this one. So I'm gonna grab it, and then we're gonna have 1752, and this is equal to 28x, I'm trying to figure out what the x is, minus 12, and then we're gonna let it do the solve for us, and this is 63. So we get 63 out of that. So n is 63. This is the number of terms in this one that are divisible by 4. And that is that arithmetic number pattern question complete. So good luck, practice it, and I'll see you in the next one.